let's check our homework answers. It was called Congruent Triangles 2. While y'all are checking your homework answers, you guys did the maze, hopefully. If you did it correctly, you would have ended right here, in the middle of the bottom. That was the correct, I think, end of the maze. Is that what we got? I have a student who's asking the difference between angle, angle, side, and angle, side, angle. So the difference is where the side is placed, where the congruent side is. Either the congruent side is between the angles, or it's not between the angles. So you go and you look for the arcs, you look for the arc markings, and you look in between them, and there's either going to be a tick mark in between them or there's not going to be a tick mark. So it's the placement of the congruent parts. That's what the difference is, whether the side is between or not between. Sometimes we call it included or not included. All right, so which one should I work from these homework questions? Which one should I work? 12, 22. Of course, yes. Okay, I'm going to start working those, okay? So on number 7, if I just gave you any triangle, and I gave you this information right here, what would you tell me about that triangle? Yeah, you would tell me that's an isosceles triangle. It's actually the converse of the isosceles triangle theorem. The isosceles triangle theorem says if two sides of a triangle are congruent, then the angles opposite are congruent. Well, this is saying if the angles are congruent, then the sides opposite are congruent. So by the converse of the isosceles triangle theorem, we can add tick marks to the legs. Those are now the legs of an isosceles triangle. Now we have multiple choices. We can write side, side, side because we have enough information for that. We can write side, angle, side because we have enough information for that. So that's number 7. We're going to look at 12 and 13 next. Number 12. So we're looking at these two overlapping triangles. We've got this one right here, and we've got this one right here. And I noticed that the blue and the red, they overlap right here. That is a shared side. So that's the reflexive property of equality. I'm going to add a tick mark. Any segment is congruent to itself. Sometimes it's really hard to see when we have overlapping pictures. So you can take one of those triangles, you can pull it out of the picture, and you can redraw it. Take one, pull it out, redraw it. What do I know about this triangle? Well, I see a double arc. I don't see anything here. I don't see anything in that corner, but I do see an arc here, right there, and then I've got my tick mark on the shared side. So when you pull it out and you look at just that one triangle at a time, we notice, oh, it's angle, angle, side. Notice how the tick mark is not between the arcs. So when I choose which theorem to use, I'm going to choose the one where the S is not between the A's. 13. 13 is going to be a lot like number 4 that we did up there. I think it was number 4. I can put tick marks on the shared side, but I don't have enough. Because it's an isosceles triangle, because those angles are congruent, I now know that those two sides are congruent, and so we're back to side, angle, side, or side, side, side again. I think it's literally the same problem, just with different orientation. Oh, it was like 7, not like 4, like 7. Okay. All right, 22, I think is honestly the same. It's very similar to number 6. I'll go ahead and do 22. We have a shared side right there, reflexive property. We've got parallel and we have congruence. See those tick marks under the parallel lines? It is important to note that. There's only one transversal here. So in this one, you don't have 2 different transversals. There's only one. Now, I taught you the other day, if you're having trouble with where the angles go, where do I put the alternate interior angles, you could always take your parallel lines and make the letter Z with a transversal. When you make the letter Z, I hope it's really obvious where those arcs are allowed to go. They're allowed to go inside the Z. So right here and right here, where those angles are. Now that I have those arcs, we've got side, and we've got angle, and then we have side. So the angle is sandwiched between the two sides. If I were to redraw that triangle, I've got my arrow, I've got my tick mark, I've got my arc, and then I have my shared side. So side, angle, side. But this lesson is going to be very straightforward and easy because we've been doing this all year. We've been justifying statements all year. But if you would like to title your notes, that would be the title, Justifying Statements. A good tool when you're justifying statements would be to have these notes for proofs. You got page 1 earlier in the year. You got page 2 maybe last unit, depending on when you printed it out. But it's a list of theorems, and there are 46 of them. Theorems and properties and definitions. There's 46. So these, the other page 2, they're like your blueprint. They're like your go-to sheet for all the different theorems you could use to justify statements. So how does this work? You will be given a true statement. So they're always going to be true. This isn't find the truth value of the following statement. No, they're going to be true. And you just need to explain why the statement is true. Tomorrow, I'll give you, so today you'll be given a hypothesis and a conclusion, and you just need to say why. Oops, that was a weird why. Tomorrow, I'll give you a hypothesis only. You'll give the conclusion and the why. And then after that, you'll just do a whole proof yourself. And you won't be given a hypothesis or the conclusion. You'll come up with all of the statements yourself. Still taking baby steps. So let's see if we can, the more you practice these, I have students say they get scared of this paper. And they say, oh, do I have to memorize all 46 theorems? And my answer is always no. You're not going to go home and memorize this sheet. The more you practice these, the more you're going to know which theorems come up over and over. Honestly, there's probably only about 8 of these that keep coming up over and over that you keep using in your proofs of congruent triangles. So are you going to need to memorize every single one? No. Have you learned all of this already? Yes. Up till, you've learned everything up to 39. And you won't use those other ones until you learn them. So you've learned everything up to 39. You already know them. Okay. So what are we doing? So these would be like the statements that you would use to prove two triangles guilty of being congruent. If BD is perpendicular to AC, so let's say in a proof I say that that's one of the givens. I'm giving you that those are perpendicular. Your conclusion would be, well, then BDA and BDC are right angles. And now we need a reason. We need a reason why those are right angles. We need to back up what we're saying. So a lot of times the answer, like 90% of the time, the answer is in the given. If BD is perpendicular to AC, what knowledge are we using to say that those are right angles? We are using the definition of perpendicular lines. If you look at your sheet and you look at perpendicular lines, the definition is two lines that intersect to form right angles. Intersect at 90 degrees. Okay? So that's the answer to number 1. Number 2. If BD bisects angle ABC, so here's my hypothesis, then ABD is congruent to CBD. Well, how do we know that? What tells us that if BD is an angle bisector, then angle ABD is congruent to CBD? Yes. So definition, very good. What tells us that? It's our knowledge of the definition of angle bisector. Are you allowed to abbreviate like I am? Yes, you are. You can use DEF for definition. You can use the angle symbol for angle. And then the B with a circle around it, believe it or not, really does mean bisector. In the math world, it means that to everybody. I didn't just make it up. Okay, next one. Ooh, BD is congruent to BD. See how we're starting to mark our picture up? Ooh, I'm about to prove these congruent by angle, side, angle. These are the steps to a proof to show that these triangles are congruent. It's pretty cool. All right, so what's the answer to this one? I've been saying this. I hope I've been saying this all unit. Reflexive. I'm skipping a word. I can't spell today. Property of equality. That weird brain fart. Okay, reflexive property of equality. Like you're looking in the reflection and you see yourself. You look in the mirror and you see yourself. You're congruent to yourself. Well, BD looks in the mirror and he sees himself. So a segment is congruent to itself by the reflexive, no C, property of equality. Okay, last one on this slide. If D is the midpoint of AC, then AD is congruent to DC. If D is the midpoint of AC, then AD is congruent to DC. And like I said, guys, almost every time the answer is in the hypothesis. This is the definition of midpoint. And unfortunately, there is no symbol that means midpoint. I wish there was. I kind of wish midpoint was like a little M with a circle around it, but that's not what it really is, even though I do that sometimes. All right, we haven't really used any theorems yet, have we? We've used all definitions. Let's look at the next one. If AE bisects BD, then BC is congruent to CD. Now, the only mistake students make on these is they get angle bisector and segment bisector mixed up. Just pay attention and you'll get it right. Notice, what am I bisecting? I am bisecting a segment. So this one would be definition of segment bisector. Whereas on the last slide, it was definition of angle bisector. Don't get those mixed up because that means you didn't really read the hypothesis. Oh, yay, we get to use a theorem. Are you ready? Here's a theorem. Okay. BCA is congruent to ECD. So we don't really have to have a hypothesis and a conclusion here. We just get to say it. We just get to say that they're congruent. And why is that? Why is that? It is the vertical angle theorem. Vertical angle theorem. VA theorem would be fine if you want to put VA. If angle B and angle D are right angles, then angle B is congruent to angle D. This one I probably haven't talked about a lot, so this might be one that you're looking on here to find, and you just need to memorize it because you know that we're going to be using it in this unit a lot. So can anyone find the one that allows us to say because they're right angles, they're congruent? It's on your sheet, but I haven't talked about it a lot. It's not an algebra property. No, Neil, no. You won't need it. You'll practice so much you won't need a word bank. Yay, ding, ding, ding. Aaliyah, it is number 17. One of my favorite numbers. Number 17, it says if angle A and angle B are right angles, then angle A is congruent to angle B. It's the right angle congruence theorem. So, right angle congruence theorem. So, out of all the things on the sheet, that's maybe one that you have to memorize. Add that to your list. You now have one thing you have to memorize because the rest of these you already know. Okay, last one on this slide. If AB is parallel to ED, then angle A is congruent to angle E. So what allows us to say that? What allows us to say that? Yep. Alternate interior angle theorem. Done. We've been talking about that ever since we learned it. That one is already committed to your memory. Okay, I have a few more. Just literally the best way to do this is practice, practice, practice. The more you see of it, the quicker you'll be. If C is the midpoint of AD, then AC is congruent to CD. Like I said, a lot of times the answer is in the hypothesis. That is definition of midpoint. That's all there is to it. If BE bisects AD, then AC is congruent to CD. Sometimes you don't even need to look at your picture. You can just literally read it and know the answer. What is happening in the hypothesis? Something is getting bisected. What is getting bisected? A segment. So, definition of segment bisector. If AE bisects BE, then BC is congruent to CE. Look at that. Same thing. Definition of segment bisector. If angle B and angle E are right angles, then angle B is congruent to angle E. We've done that on the last slide. This is, remember, the only one that's probably new. Right angle congruence. You can write theorem at the end because it is a theorem. Right angle congruence theorem. If AB is parallel to DE, looks like we're doing the last slide all over again, doesn't it? Then, ooh, it makes us fill in the blank here. Then, angle A is congruent to angle D, alternate interior angle theorem. Cool. BCA is congruent to ECD. Which one is that? BCA is congruent to ECD. Oops. Vertical angle theorem. VA. All right. So we're not going to do this next activity